Hello. Good evening, everyone. Am I audible?
Good evening, sir. Yes, you are audible.
Okay. So let me share my screen. Just give me a minute. Do you have any question from the last class? Before starting that, we can take the questions from the last class. So today's fifth class, right? It is 26th. If anyone have any question from the last class, you can ask now, or we'll start then.
Sir, you told you will share all the data, but we could not receive it.
I have shared the notes, whatever I have written in the last class. I have shared that in the Google Drive link of the note was shared in the weekly log sheet. Do you have the access of the weekly log sheet?
No, sir.
Okay, how is it possible? Okay, so let me share the link of that. Just give me a minute. So, so Google Drive link is. Just give me a minute.
Sir, can't we have that link on that NPTEL board?
I have shared a link in the chat box. So let me know if you can access that link. There are all the details of all the classes. You have the YouTube link as well as the Google Drive link of all the classes, like from mine and all the other TAs also. So let me know if you can access to this link. Can you access the link and get all the details? So in the sheet 1, there is the details of Aishwarya and Sunit, and then in sheet number 2 there is the YouTube link and the Google Drive link for my classes. So have you able to? Hello, am I audible? Hello, hello. I don't know.
Yes, sir.
So in the chat box I have shared a link. So have you get that link?
Yes, sir.
So you can see the table of YouTube links and all the details about the notes also.
Yes, sir. Now it is accessible.
Yeah, so there this Google Drive link, you can go there and all the notes for previous 4 classes are there. You can get the class notes from there.
Thank you, sir.
Okay. So in this last class someone was asking about which Miller indices are allowed for which lattice structure. So that comes from this structure factor or atomic factor. So I'm gonna discuss about this uh, in brief, so you can get an idea about those things. So this structure factor wait a minute. So the scattering amplitude actually defined by this f, which is given by some integration of this volume, then ANR, which is the electron density, and then exponential minus I delta k, or it is delta k actually g. This is the reciprocal lattice vector g dot r. Then it can be written as an NR is actually given by this. J is number of atoms, then Nj r minus rj. This derivation you can find from any of these books. So F can be written as dv Nj r minus rj exponential I minus I g dot r. And sum over j is there also. Now we define the structure factor as S of j, which is given by sum over j dv Nj r minus rj into exponential minus I g dot r. So in terms of Sj, this is what we get, and then we write Fj as dv Nj. So yeah, so this can be written again as sum over of j exponential minus I g dot rj integration of dv Nj. Now r minus rj is written as rho and exponential minus I g dot rho. So from this line to this line we have done that, we have added an extra exponential minus I g r minus rj, and then since we have added plus I g dot rj, we have subtracted this here. So this is the extra term which we have added and subtracted. So and rho is r minus rj. So this can be written as sum over j of fj exponential minus I g dot rj. Here fj is integration of dv Nj of rho exponential minus I g dot rho. So from this, these are the position of the atoms in a basis. So for a particular lattice, let's say Rj is given as xj a1 plus yj a2 plus zj a3. Here a1, a2, a3 are the real space lattice vectors. And you know that G is a reciprocal lattice vector which can be written as u1 b1 or v1 b1. I am writing the same notation, plus v2 b2 plus v3 b3, where b1 b2 b3 are the reciprocal lattice vector. So you know that the for ai dot bj is 2 pi delta ij. This is known. that is, if we do that a1 dot b2, then that will be 0. Similarly, a1 dot b3 is also 0. only uh, Only a1 dot b1 is 2 pi and a2 dot b2 equal to a3 dot b3 is 2 pi. So from there we can get what is g dot rj. So g dot rj is equal to v1 b1 plus v2 b2 plus v3 b3 into, and what is what is rj? Rj is xj a1 plus yj a2 plus zj a3. From there we get v1. Now a1 dot b1 is sorry, so a1 dot b1 is 2 pi, so it will be 2 pi into v1 xj plus v2 xyj plus v3 zj, because only this same indices will give us 2 pi, and if we dot product between b1 dot a2, that will give 0. Similarly, b1 dot a3 is also 0. Only b1 dot a1 is 2 pi, so b1 dot a1 will give 2 pi, and these coefficients are b1 xj. Similarly, for b2, if we do the dot product, then we will get v2 yj and v3 zj for b3. So this is what we get as z dot rj. Now sj can be written as sum over j fj exponential minus I, because it was exponential minus I g dot rj. So it is minus I 2 pi into v1 xj plus v2 yj plus v3 zj. This is the relation for the structure factor. So from this relation we can calculate what would be the allowed HKL value for any reciprocal, so for any lattice vector. So let's say if we want to calculate this for let's say for BCC structure. So we know that BCC have two atoms, the basis has two atoms, and if we say, let's say for BCC, so if we repeat the same thing here, what we did is this is the amplitude, scattering amplitude, then G is the reciprocal lattice vector, and R is the position of atoms, Rj is the position of atoms. So we have calculated what is the structure factor, and then this is the atomic factor. So structure factor is given finally by this expression. So if structure factor is 0, then we would say that that diffraction is not allowed for. So from the value of this structure factor we can say which reciprocal which Miller indices are allowed. So for BCC we know that the basis atoms are at 0 0 0, so the identical atoms will be at, so x1 y1, the atoms are at 0 0 0 and half. If the atomic constant is taken as 1, then the atoms are at 0 0 0 and half half half. So if we calculate this, then what will be the value? So we need to calculate what is v1 xj plus v2 yj plus v3 zj. So that will be, for 0 0 0 it is 0, and for the case 0 0 0, and this equal to will be, okay, so half, so v1 by 2 or v1 plus v2 plus v3 by 2 for the point half half half. So this corresponding to this point, and this 0 corresponds to this point. So now if we do the, so from this formula what we will get is Sj equal to sum over j. So for this point, j is here 1 and 2, so two atoms are there, so j is 2. So for the first case it is, and let's say f are equal for both the cases, so f into exponential 0, that is 1, so f is f plus f into exponential minus I 2 pi, and this value is v1 plus v2 plus v3 by 2. So from there we will get f plus f into, this 2 to cancel, exponential minus v1 plus v2 plus v3 into pi, right? Or it can be written as f into 1 plus exponential minus v1 plus v2 plus v3 into pi. Now you can take different combination of v1 and v2 and v3. So v1, v2, v3 is basically h, k and l. It is written in these terms. So if v1, v2, v3, so when it would be 0, so this is 1, and if this value gives us minus 1, then it will be 0. So when it will give us minus 1, oh, so if there was an I exponential I, so I will be there. So let's say all of them are odd. So if we take 1 1 1 value, so if we take 1 1, or let's say 1 0 0 value for HKL, then it will give us exponential minus I pi. And exponential minus I pi is what? It is minus 1, right? Because cos pi plus I sin pi, so minus 1, so that will give us 0. So have you understood this? Let's say v1, v2 and v3 are all odd. If they are all odd, then the v1 plus v2 plus v3 is also odd. It can't be even, because 3 odd numbers will give us, the addition of 3 odd numbers is odd. So it will be f into 1 plus exponential minus I into some odd value of n into pi, that is 2n plus 1 into pi, where n is any integer value. So this will give us minus 1, because exponential of minus I pi, you can write it as cos pi minus I sin pi. So any number, any odd value of odd multiple of pi will give us minus 1. So this value will give us minus 1. So f into 1 minus 1, that is 0. And if you take some value of v1 v2 v3 in such way that v1 plus v2 plus v3 is even number, if it is even, then what will be the value of Sg? Sg will be f into 1 plus exponential minus I into 2n pi. Now exponential minus 2n pi is what? 1. So it will be 1 plus 1, that is 2f. So you need to take such values of v1, v2, v3 or HKL, so that the addition of these three numbers v1, v2 plus v3 will be even. If this number is odd, if it is even, then s is equal to 2f. And if v1 plus v2 plus v3 is odd, then a is equal to 0, as you can see. So from there you can say that the diffraction pattern does not contain lines such as for 1 0 0. Let's say if we take this 1 0 0 plane, then v1 plus v2 plus v3 is odd, so there will not be any diffraction pattern. Similarly for 300 there will not be any pattern, but for 111, 110, let's say 200, these values are allowed for, because they will have a diffraction pattern. Similarly 111 is not allowed, because then S will give us 0. So is it clear how what values of this HKL are allowed for BCC structure? Similarly we will do for FCC also. So is it clear for the BCC first? Does anyone have any question? Someone also joined the
Sir,
call. Yes.
you just told that 110, 200 will have diffraction pattern.
Yes.
Okay?
Yeah.
Okay. Okay.
Because they will give us S equal to 2f. Is this argument clear how it is given as 2f? So we you need to do for, so you will start from this expression, okay, that let's say it is equation 1. For any lattice structure you will start from this expression, and we'll see if a is equal to 0 or finite. If a is equal to 0, then that combination of HKL are not allowed, and if it is a finite non-zero value, then that will be allowed. So this was for BCC structure. So similarly you can argue what will be the values for FCC structure. So you know that FCC structure has the basis has 4 atoms, and the 4 atoms are, so if we do for FCC structure, for FCC structure the bases are at 0 0 0. So if we draw that, draw this in this way. So let's say this is the cube. So in FCC lattice there are atoms in there 8 corners, as well as on the face of every face of this 6. Yeah. So we know that FCC has 4 atoms in their bases. So let's say this is one, this is another one, and the coordinate of this will be half 0. Then this one, the coordinate of this is 0. Okay, so in the x-axis you need to go half, so half of 0. Okay, so this is the 0, sorry, this is not the 0, this is 1 is 0. So let me write it again. So this one is the 0th atom, and this is half 0. Then there will be another atom at here which is half 0 half, and another one is 0 half half. So these 4 atoms are the basis of this BCC structure. So for these 4 atoms you can calculate what is the what is this value, where is it, this value. So you need to calculate this value for all the 4 atoms. So let's copy this. So you can calculate this value for all the atoms. For the 0 0 case it is 0. For the 0 0 point, this value is 0. For the point half 0, this value is, so you need to calculate this v1 by v1 plus v2 by 2. Similarly for half 0 half, it is v1 plus v3 by 2, and for 0 half it is v2 plus v3 by 2. Now add all of them to calculate Sg. Sg is f into, so exponential of 0 will give us 1 plus exponential of this value is minus I pi. So there was 2 pi there, 2 pi so 2 pi was there, and since v1 plus v2 by 2, 2 cancels out, so we will have minus I pi into v1 plus v2. Similarly for the other two cases also you will get exponential minus I pi into v1 plus v3 plus exponential minus I pi into v2 plus v3. Now you will have to take different combination of v1 v2 and confirm that what values are applicable. So let's say if v1, any of the two are odd and one is even, so two odd number will give us one even number, and another even number is even number. So let's say v1 and v2 are odd and v3 is even. So in that case v1 plus v2 will be even, and even number of these will give us plus 1, and v1 plus v3 is odd, v1 plus v3 is also odd, so this will give us minus 1 minus 1. So 1 plus 1 minus 1 minus 1 will give us 0. So in details, if we argue that Sg will be f into 1 plus exponential minus I pi. So v1 plus v2, v1 and v2 are odd, so the addition of v1 plus v2 will be even. So I will write it as 2n, and exponential of, now since v1 is odd and v3 is even, then v1 plus v3 is odd, so it will be minus I 2n plus 1 pi. Similarly for the last case also it will be odd, because v2 is odd and v3 is even, so it will be 2n plus 1 into pi. So in that case it will be f into 1 plus, this value will give us 1, but this is minus 1, this is also minus 1, so minus 1 minus 1, and it will be 0. So for this I took as v1 v2 as odd and v3 as even. So if you can take any arbitrary two coefficients as odd and other as even. So if you take v1 and v3 is odd and v2 is even, the same case will occur and the Sg will be 0. Similarly for the other case, that is v2 and v3 is odd and v1 is even, you can argue similarly that Sg will go to 0. So any two number odd and other is even will make this Sg vanishing. Similarly if we do two number as odd, two number even, so what we did here is v1 v2 odd. So let's say if we take v1 v2 as even and v3 odd, so in that case also you can see that Sg will be f into 1 plus exponential minus I pi Now v1 and v2 are taken as even, so the addition of v1 and v2 will be again even, so that will be 2n plus exponential minus I. v1 and v2 are taken as even. Now v2, so v1 plus v3 is odd because v3 is odd, so plus 2n plus 1 into pi, and the another case is also minus I 2n plus 1 into pi. So in that case also f into 1, this will give us 1 plus minus 1, this is also minus 1, so this will vanish. So if any of the two numbers are odd and another one is even, or any of the two numbers are even and another was odd, then SG will vanish. So let's say if we take all of them as odd, so let's say v1, v2, v3 all are odd, everything is odd. So I won't calculate it here, but I'll show it that if let's say v1, v2, v3 all are odd, so this is even, this will also be even, this will also be even, because two odd numbers will give us even value. Okay, some people wants to join. Yeah, so in that case this will give us this 1 is already there, plus 1 plus this will also give us 1 plus this will also give us 1, so we'll have 4f. So in case of all the values as odd, SG will be 4f. And if we do v1, v2, v3 all as even, all are even, then also we'll get SG equal to 4f. How do we see that? All of them are even, so this is even, this will also be, this is even, this will also be even, and this will also be even, so this will again give us 4f. So for FCC structure what we get is SG equal to 4f if all the coefficient, all the v1, v2 and v3 are odd or even simultaneously. I mean they are simultaneously odd or simultaneously even, then it is 4f, or equal to 0 for other condition, for any other condition, for any other condition. Yeah, so either all of them has to be even, so what values are allowed here? So let's say 1 0 0 is not allowed because here two are even, one is odd, so it is not allowed. Similarly 1 1 0 is also not allowed because two are odd, one is even, but 1 1 1 is allowed because all of them are odd. Similarly 2 2 2 is also allowed because all of them are even. So that's how we can say that what of the Miller indices that are allowed. So did you understand the argument for the FCC structure? Is there any question? I guess I'm audible, right? If you have any question you can ask how, or I'll, so if you understood this too, then you can also do that for diamond structure. So in diamond structure there will be 8 atoms in a basis. So for FCC structure we have seen that there are 4 atoms, for VCC there are 2, but for diamond structure there are 8 atoms in the structure. So you will see that there are also an atoms here, so there are 4 or more atoms inside the lattice, and the position of these 8 atoms you can find out, and then do the similar calculation, and you will find that the for diamond structure the allowed value of HKL would be some either all of them are odd or even, and even integer of 4n. So using the same argument you can calculate for diamond atom also. So let's make it a homework for the next week. So I'll ask everyone to show the diamond structure factor first you have to do, what you have to do is write down the coordinates for the 8 atoms which are in the basis, and then similar calculation, just you do this, you find out this value, yeah, you find out this value, and then you can argue that for what values of v1 v2 v3 or hkl this structure factor is non-zero. So if you have any question you can ask, or I'll solve few question from the previous year's assignments.
Sir, can you repeat the homework question?
Homework question is for diamond lattice structure. So this was BCC and FCC. Similarly, if you have diamond lattice structure, then what will be the allowed values for H, K and L?
Okay, okay, sir.
So for diamond there are 8 atoms in the basis, and write down the coordinates for the 8 atoms. So I'll write down the coordinates maybe for diamond atoms. So the coordinates will be 0 0 0. Then there will be an atom as 1 by 4 1 by 4 1 by 4, 0 half half. So the basis will have atoms similar as FCC, and there will be 4 extra atoms inside the lattice. So these coordinates will be there, these 4 atoms will be there, and there will be extra 4 atoms inside the lattice. So if you see the diamond structure you can search it out and see the diamond structure, then it will be clear how these atoms are coming in the basis. So then there will be 3 4 3 4 1 4. Then there are 1 4 3 4 3 4. There will be also an atom as 3 4 1 3 4. Then half 0 half 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 0, and so how many, 1 2 3 4 5 6 7 8, yeah. So these are the coordinates of the 8 atoms. So using these 8 coordinates and similar procedure you can calculate what is the allowed values for diamond structure. So if can anyone confirm that if this assignment was solved or not? Assignment 5, yes. Can you see the assignment here? Hello.
Yes, sir. Yes, sir.
So these questions were solved in the last class or not? Can you confirm?
No, sir. No solve.
Okay, okay. Okay, so I'll solve these questions.
Actually, assignment number 5. Please discuss some things about question number 10.
Question number 10. So are you referring to this question? So this assignment is not for from this year's. This is a previous, maybe
Oh,
2019's question.
okay, okay, sir. Okay. This is not current assignment.
Yes, this is not the current assignment because I can't solve current assignments of assignment 5. It is also like the assignment is not the due date is still not crossed. But yeah, these questions are of similar types, so I can solve this old assignment, which will help you to solve this assignment, current assignments also. So the first question I'll write down. So let me know if any of the questions are solved, then I'll not discuss that question.
Sir, previous assignment, that is assignment number 4. Can we discuss something about the question number 6?
Previous assignment, question number 4.
6, sir. Assignment 4, question number 6.
Okay, I have to, I have to check where it is. Question, assignment 4. Is this assignment 4? Yes. Are you talking about this assignment? Oh, sorry, question number 6. Is this assignment?
Yes, question assignment number 4.
The first
We,
three lines from the powder pattern of cubic crystal have the following as values. This question, right?
yes, sir.
Okay, let me see. The first three lines from the powder pattern of a cubic crystal have the following is values: 24.95, 40.90, and 48.05 millimeter. Camera radius is 57.3 millimeter. Molybdenum K alpha radiation of wavelength 0.71 angstrom is used. Determine the structure of the material. I think okay, diamond cubic structure. I also don't know what is A's values. Do you know what is A's values?
Actually, this class was not done here.
So why it is then in assignment number 4 if the lecture is not uploaded yet? So it should be in assignment number 5, I think. Then so yes, if you have as you have pointed out, so I'll solve it and I can send you. Hello, am I audible? Hello,
Sir, cannot not hear your voice, sir.
am I audible now?
Sir, we are not audible.
Yeah, now
Breaking.
audible, sir.
So
Sir, now
yeah,
audible.
yeah, yeah. So I also don't have idea about A's value, so I can solve it and can send you, or maybe I will add in the notes, today's notes. Is it fine if I solve it later and add in the notes, or I can also discuss in the next class also, if it is
Okay,
fine.
sir.
Okay, sir.
Sir, I have one doubt, sir.
Yes.
For this week, fifth assignment related. I think that from previous year question paper, model question is there means discuss about sixth question and eighth question pattern, sir.
So about assignment
Si-
5,
yeah, sixth and eighth question. That pattern not discuss about any question for previous class, sir.
this so I'm sharing this question number 6. So are you talking about this question?
Not this question, that live assignment
Oh, this
5.
live assignment,
Not,
assignment 5.
that related. For example of any one of example problem you can solve means easy, sir. That is some difficult.
Well, let me check.
Actually, sir, current assignment number 5 में
Hmm.
question number 8, question number 10, that type of question was not discussed in the class.
Six also, sixth
6
and
also.
eighth pattern.
Okay,
A
okay,
lot
okay.
of confusions are there only.
6th and 8th.
10.
8 is fine. So 10, 6th and 10.
Yes.
Find out reciprocal vector for a space that is defined by the following primitive translation vectors a, b, and c, I, j, and other universal respectively. So 10 is a straightforward question. A, B, C are given.
10 is already discussed about, I think yesterday or before yesterday, Sunit sir or
So
Sunit das, I think.
yeah, so you are talking about
And
6th,
eighth and fifth pattern not discuss about any question, sir. That is like little bit
8th and
confusion.
6th, right?
Yeah, sir.
So 6th So 8 is a two-dimensional revised lattice has the primitive vectors a1 and a2. Compute the primitive vectors of the reciprocal lattice. So it is also a easy question, right? Just you need to calculate the reciprocal primitive reciprocal lattice vectors. So why it is difficult?
So that problem only confusion. Already I am having the problem for three-dimensional 2 by into B cross C
Okay, so
dividing by A like that.
so for
But
two,
two-dimensional means A dot A star equal to 1 like that only I have studied.
so
But
for
here what is the
yes,
formula?
for 2D, for if you have two lattice vectors, then what you need to do is you take a3 as z cap, just z cap or j cap, okay, and then you calculate a2 cross a3 and a1 dot a2 cross a3. You take a3 as z cap or k cap, sorry, not j cap, z cap
Sir,
or
if
k
you
cap.
not given two-dimensional given also, are you taken that A3 equal to K?
A3 you are assuming
Are you
that
mentioned that two-dimensional means are you taken in A1 and A2 only, sir?
yes, a1 and a2 are already given in the question. A2
Okay.
a3 is not given, but you will take a3 as z cap.
Let us assume that A3 value.
Yes, you will assume that a3 is
So,
z cap.
that means are you using the same formula?
Yes, you will use the same formula,
Yeah.
but you will take a3 as z cap and not a z cap.
Okay.
A is 1.
Okay, now understand, sir.
Yes, for any kind of 2D problem, you will take a3 as z cap. Okay,
Okay, sir. Thank you. Thank you.
but I will not solve the problem now because it is not yet the due date. You have not submitted the question yet, so I will not solve it right now. And for this structure, you need to find the HKL the family. So what is not clear here for the question 6? Who was saying that question 6 is also not clear? Can you say what is
Yeah.
confusion?
Sir, that is lowest and highest reflection. Asking the question for lowest and highest reflection.
Okay,
That
determine.
means D proportional to root of h square plus k square plus L square formula
Yes.
only are you taken, sir?
Yes.
Yeah, that means here lowest and highest, both are things in the same model. Any problem is there means you can explain, sir. Not like this problem. Any other model problem is there means once explain, sir.
Okay, so if there is any problem in the last, sorry, 2000. Let me see if there is any problem in the. So I have not gone through it yet, but I have to check if there is any problem like this only.
Okay, sir, no
So
problem.
can you start? Can we start here and then we will solve? So is question 5? Let's say question 5 is it solved in the last class?
This, yes, sir. Last class this question solved.
Then there is one more interesting question I have found. Let's say question number 8. Is it solved?
Thing not solved, sir.
Okay.
Not solved.
So this is also a little bit tricky question. Uh, Not that much tricky. It's also an easy question. So can you solve this question? Like you have solved already a lot of question from this diffraction pattern. So can you solve question number 8? Everyone, please solve question number 8 and let me know the answer. This is a good question. Like this kind of question can appear in competitive exams also. someone has already solved. What about others? So someone has already solved. Others, did you solve?
No, sir, please you explain.
Okay. So let me just give you some. So someone is saying option A, someone is saying option C. So let me just solve this. So it was question number 8. Just give me a minute. I'll check, see the question where things. So let me also write. So for the note purpose, I'll write down the question also. The unit cell dimension, all that is constant. A of any cell lattice is 4.92 angstrom. If an X-ray beam if an X-ray beam of wavelength lambda which is equal to 1.1 angstrom falls on a family of planes with a separation of a by root 5 angstrom, then the maximum how many orders of diffraction are observable. And the options are 2, 3, 6 and 4 and 6. So you need to use that formula, that 2d sin theta equal to n lambda for X-ray diffraction. So you know that theta can't be more than 90 degree, right? The maximum value of theta can be 90 degree because you are having this kind of diffraction. So this is theta. So light can that theta value can have maximum 90 degree values. So because this is also theta, so this diffraction, so it can be diffracted like maximally this way. Is it so? This is theta. Yeah. So this theta, maximum of theta can be 90 degree. So for maximum value, you take theta as 90 degree, and d is given as a plane separation is a by root 5, and a is also given as 4.92 degree, 4.92 angstrom by root 5. So you need to calculate, and lambda is also given, which is 1.1 angstrom. So you have to find the values of n. From there you can find that 2d is 4.92 by root 5, and sine 90 degrees 1 in n into lambda. Lambda is 1.1. So from there you will get that n equal to 2 into 4.92 divided by 1.1 into root 5. So calculate this value in a calculator. 2 into 4.92 divided by 1.1 into root 5. So it is nearly equal to 4. So the maximum number of diffraction pattern, order of diffraction will be 4. So the correct
Sir, suppose are you considering a by root of 5, sir? Are you HKL value are you adding? You got the root of 5 on the formation. Are you writing? Na? That is correct or not, sir? Separation of HKL value.
yes.
If you added 5, we got how many values are you got? That value are you written? Na?
So
So
actually,
for example of 210.
so HK, the information about HKL is not given in the question. It
Yeah,
already
not given, sir, but here indirectly given a by root of 5. Root of 5 value is HKL value, na?
so h square plus k square plus l square is 25. Oh, sorry, 5. Yes. So root over of h, you know that d equal to a by root over of h square plus k square plus l square. So this instead of h square plus k square plus l square, this 5 is already given. So you don't need to do anything with HKL. You just use the formula for the expression of d, and which is given as a by root 5, and the value of a is also given. So you don't need to know what is HKL separately. So what was your
Okay,
question?
okay.
Yeah. So anyway, what were you asking? Is it what you asking, that if HKL is needed or not? Like in this question, D is given, and you need to find out what is N. So you don't need the information about A or anything. So D is given in terms of A, and the value of A is also given. So HKL is not needed. So using this, you will find that the correct answer is option C, that is N is 4. So any kind of question like this, if you need to find out what is the maximum number orders of diffraction, then you will use theta max is equal to 90 degree, and then using this formula you can find out what is the value. So you said that question number 6 was done. So sorry, question 5 was done. So can you calculate, if I ask now, can you say how do you calculate this question number 5?
Sir, not solved by me.
Yeah, so yeah, I'll discuss this, because this is a good question actually. Everyone solved it question, question number 5.
Sir, yesterday madam is solving, sir.
Can you solve it now, or can you say how to calculate this now, if you understood?
So they are only taken AB equal to BC, the triangular. That
Yes.
value is 2 Armstrong. After that, AD equal to BC,
Hmm.
that value equal to 3 Armstrong.
Hmm.
After that, let us considering DAB.
Okay, then.
DAB, the angle of 45 degree.
Hmm.
After that, A equal to A cross B. A cross B means here AB sin theta. Now area only calculating 6 by root 2 A square. After A dash equal to 2 by B vector by area. And the same B dash equal to 2 by A vector by area. Like this type only calculated, sir.
Okay, it was not clear to me also.
There only already if you discuss about the n value equal to odd and f value equal to n value equal to even or odd, no, what is the frequency intensity value 4f square only find out.
Okay, the most of the part was not clear to me also. So
Once again you can explain, sir, no problem.
let me write down it. So these kind of questions are not very trivial. Like in few questions there are just A and B are given, and you need to calculate what is the reciprocal lattice vector. So these are trivial. Just you just use the formula. But here you need to build the vectors also. So two-dimensional direct lattice be formed from a repetition of primitive cell ABCD as shown in the figure below. The length of the primitive translation vectors of the direct lattice where A equal to AB equal to DC and B equal to AD equal to BC equal to 3 angstrom. So the angle DAB equal to 45 degree. Then calculate the length of the primitive vectors of its reciprocal lattice. So I'm not writing down the option. Let's first find out what is the answer. So this is given like this. This is A, B, C, D. Here B is 3 angstrom. This angle is 45 degree. sorry. What's happening? So this angle is 45 degree and A equal to 2 angstrom. So the real space lattice vectors are exactly not given, but it is given in some extent. So let's say this is x-axis and this is y-axis. So x-axis and y-axis are orthogonal to each other. So let's say this is y-axis. So A vector you can write out. So let's say A vector is along A is given along x direction. A is actually AB vector. So these are the two, AB vector and B vector is AD vector. So these are the two lattice vectors, real space lattice vectors. So this is A vector and this one is B vector. So using this A vector and B vector you can find out the whole lattice. So these two vectors are the lattice vectors. So lattice vectors are meant to be these two vectors, which are with these two vectors you can repeat the whole lattice. So now A vector is already given in the x direction. So A vector is A x cap. And why I'm using red color? So A is AB vector, which is A into x cap, and A is 2 angstrom, so 2 x cap. Is it clear how A vector is 2 x cap? Hello.
No, sir, you
Yes,
make it
clear,
clear,
clear.
please. You make it clear, please.
Yeah, so A vector is 2 x cap because A vector is this vector, AB vector. So AB, the value of AB is 2 angstrom. It is already given and it is in x direction, already in x direction, so it is 2 x cap. Now you need to find out what is B vector. V vector is AD vector. Now you know that if a vector is given in a space like this, then it has a x component and y component, and if this angle is theta and the value of this is let's say some value p, then the x component is p cos theta and the y component is p sin theta. Similarly, this AD vector has value 3 angstrom. It is already given in the question, 3 angstrom. So it has x component. So x component is 3 cos theta. Cos theta is 45 degree plus it is in the x direction, and a y component. Y component is 3 sin theta, sin 45 degree y cap. So is it clear how I have written the V vector? V vector is not given in the y direction. It has an angle with the x direction. So you need to take the two components along the x direction and y direction. So you know that any vector with angle which is making an angle theta with the x axis, it has a x component which is a cos theta and an y component which is a sin theta. So any arbitrary vector, let's say x vector, it can be written as, if it has value a, then it can be written as a cos theta x cap plus a sin theta y cap. So that is what I have did here. If the value of AD is already given as 3 and the component along x direction is 3 cos theta x cap and along y direction is 3 sin theta y cap. So is it clear? If this is clear, then the rest of the problem is easy.
Yes, sir.
So you write down this as, so cos 45 degrees 1 by root 2, so 3 by root 2 x cap plus sin 45 degrees also 1 by root 2, so 3 by root 2 y cap. So you have found what is A vector, what is B vector, all, so two vectors are found. Now you need to calculate the reciprocal vector of A. So let's say I write the reciprocal vectors as A1 and B1. So it is given in 2D. So I already said for 3D you need to take another vector C, let's say C, which is only Z cap. So for any 2D problem, to calculate the reciprocal vectors, you need to take assume one vector C which is Z cap. So now you can calculate all this thing. You have A vector, B vector and C vector. So if I write it again, A vector is 2x cap, V vector is 3 by root 2 x cap plus 3 by root 2 y cap, and the c vector is z cap. So it is not given, but you will assume that the c vector is z cap. So to calculate the reciprocal vectors, you need to calculate what is a dot b cross c, because you know the formula for reciprocal vectors is 2 pi into b cross c by a dot b cross c. This is the formula. So you need to calculate what is the volume, that is b cross c. So that can be found. So first you calculate what is b cross c. So x cap, y cap, z cap. The component of b vector is 3 by root 2 x cap, 3 by root 2 y cap, and z cap is 0. And for c vector is only z cap, so this is 0, 0 and 1. So it has component x 3 by root 2 minus y cap into 3 by root 2. So b cross c is found. Now you need to calculate what is a dot b cross c. So a is just x cap, so 2x cap in dot 3 by root 2 x cap minus 3 by root 2 y cap. So this will be 6 by root 2. Now you can calculate the reciprocal vectors a1. So a1 will be 2 pi into b cross c. B cross c is what? 3 by root 2 x cap minus 3 by root 2 y cap. And what is a dot b cross c? It is 6 by root 2. 6 by root 2. So if you do this, 2 by pi into 3 by root 2 common, and this will be root 2 by 6 into x cap minus y cap. So root 2 cancels out, 2 cancels out, so pi into x cap minus y cap. This is a1. So what was the question? Question said that find out the see the questions. So it said that calculate the length of the primitive vectors. So this is the primitive vectors a1 reciprocal vectors. Now the length is only find out the mod value of this, pi into root over of 1 square plus minus 1 square, that is root 2 pi angstrom or pi root 2 angstrom inverse. Is it clear how I calculated the value of a1? The like if you understood how to calculate the value of a1, then you can also calculate what is the length of the vector a2 also.
The final step determinant of A1, sir. A1. That's only once you can explain, sir. X minus y cap value.
This
Final step, sir.
yeah.
Yeah, last one.
So a1 is pi into x cap minus y cap, because I have cancels out all the
Okay.
things. So pi minus x cap. This is the vector. So how do you calculate a vector's norm? So this is a vector. Then you mod value of vector a1 will be, let's say if a vector is a x cap plus b y cap, then the mod value will be root over of a square plus b square. So similarly I did here is root over of, so it is actually a pi x cap minus pi y cap, right? So it is pi square plus minus pi square, which is pi
Okay,
square
okay, okay.
plus pi square root, that is equal to pi root 2 angstrom inverse. So can you then calculate what is the reciprocal lattice length of the b vector's reciprocal lattice vector? So this was a1 was reciprocal lattice vector of a vector. Now calculate the reciprocal lattice vector of b vector. Similar way, so the formula will be b1, which is equal to 2 pi c cross a divided by a dot b cross c. So a dot b cross c is already calculated as 6 by root 2. You just need to calculate what is c cross a. So c and a all both are given. C is z cap and a is 2x cap. So using this you find out what is c cross a and then put it down in the formula of b1, then find out what is the vector b1. Everyone do that and let me know what is the answer.
2 by 3 pi root 2 angstrom, sir.
2 by 3 pi root 2. Okay. Yeah. What about others? You can also calculate it in 2 root 2 pi root 3 angstrom inverse. Yes. So c cross a is very easy to calculate. C cross a is just z cap cross 2x cap. So 2 into z cross x cap is only y cap. So 2y cap. So b1 vector is 2 pi into 2y cap divided by a cross b cross is 6 root 2. So 4 by 6 which is 2 by 3. So 2 by sorry 6 by root 2, it was 6 by root 2. So 2 by 3 root 2 root 2 by 3 y cap. So the value of that is the mod value of b1 is 2 root 2 by 3 angstrom inverse.
Sir, I think pi is missing.
Pi is missing. Yes, sorry, pi is also be there. So that's pi. Yeah, there will be pi also. So for the this question, so is this clear?
Very good, sir. Thank you.
Okay. So okay, let me see. So I have a question for a hexagonal lattice. So can you calculate this? So there is a question from hexagonal hexagonal space lattice. So the primitive translation vectors of the hexagonal space lattice may be taken as a1 is given by root 3a by 2 x cap plus a by 2 y cap. A2 is minus root 3 by 2 root 3a by 2 x cap plus a by 2 y cap, and a3 is cz cap. Show that the volume of the primitive cell, so this is not a so this is not a MCQ question, it's to prove that, or let's say find the volume of the primitive cell. Find the volume of the primitive cell, and then the also question B is find the primitive translation vectors primitive translations of the reciprocal lattice. So please do this question. So first you need to do the first you need to calculate the volume of the primitive cell. So volume of not the reciprocal cell. In the real space, what is the volume of the cell, and then find out what is the reciprocal translation vectors. So a1, a2, a3 are given. If anything is not clear, then ask, but you have to do this question.
Sir, volume is root 3 by 2 a square c. Hello, sir.
Yeah. Hello.
Sir, volume is root 3 by 2 a square c.
1 minute. Let me check the answer. So volume is root 3.
Root 3 by 2 a square c.
Yeah, volume is correct. And the reciprocal lattice vectors. Have you calculated the reciprocal lattice vectors?
Sir, I am calculating, sir.
Okay, sure. So others also please calculate the volume of the reciprocal lattice vectors and then calculate the primitive translation lattice vector and also the volume of the primitive translation. Sorry, primitive reciprocal lattice vector. Hello. At least the volume have you calculated?
Volume calculated, sir. Primitive now only calculated.
So volume will be given by a1 dot a2 cross a3, this norm of this. So first you need to calculate what is a2 cross a3, and that will be given by x y z. a2 cross a3 is minus root 3 by 2 a by 2 0 0 0 c. So from there you will find that x cap is equal to ac by 2 minus y cap, so will be plus root 3 ac by 2. So what will be a1 dot a2 cross a3? a1 is given as root 3 a by 2 x cap plus a by 2 y cap, and this is ac by 2 x cap plus root 3 ac by 2 y cap. So it will be root 3 a square c by 4 plus root 3 a square c by 4, that is root 3 by 2 a square c. So this is the volume of the primitive unit cell. Now what was asked in the question, to find out the primitive translation vectors of the reciprocal lattice. So this volume is already known, then you can find out what is the b1 b2 and b3. If b1 is the vector, then b1 is 2 pi into a2 cross a3 divided by root 3 by 2 a square c. a1 dot a2 cross a3. So 2 pi into a2 cross a3 is already calculated, which is ac by 2 x cap, ac by 2 x cap plus root 3 ac by 2 y cap divided by this value root 3 a square c by 2. So that 2 will go up, we will get 4 pi by root 3 a ac cancels out, so x cap plus okay, so 2 will come out, so 2 pi will be there, 2 pi, so x cap plus root 3 y cap. So is that the value you found for b1? Does it match with your answers? So what I have found is
Yes, sir.
2 pi by root 3 x cap plus 2 pi, yeah, so this is b1. Then for b2,
Sir, I have calculated B2,
what is b2?
2 pi by root 3a
Yes,
in bracket x cap minus root 3 y cap.
okay, so let's calculate this. a3 cross a1 divided by a1 dot a2 cross a3. So if I have to find out what is a3 cross a1. So a3 was given as cz cap cross a1, and a1 is root 3 a by 2 x cap, root 3 a by 2 x cap plus a by 2 y cap. So this will be root 3 ac by 2. Now z cap into x cap will give us y cap plus z cap into y cap will give us minus x cap. So this will be minus minus AC by 2 x cap. You can also calculate it by from this determinant kind of thing, but since it is easy cross product, we just calculate it directly. So this is A3 cross A1. Now put down this value 2 pi into root 3 AC by 2 y cap minus AC by 2 x cap divided by root 3 square C by 2. So 2 cancels out, this 2 will cancels out with this 2 and a square c cancels out, so we will be left with root 3a, and here it will be root 3 y cap minus x root 3 y cap minus x cap. So I think there will be a minus sign. Whoever said the answer, you said x cap with plus sign and y cap with minus sign, but the answer will be opposite, I think. So it will be root 3 y cap minus x cap, or you can, if you want to write it as this, then minus x cap plus root 3 y cap.
Yes, sir.
Yeah.
Sir, I
So
have calculated also B3.
so what did you find B3?
2 pi by C z cap.
Yes, yes, fine. So B3 is just A2 cross A3 divided by A1 dot A2 cross A3. So it will be, so you need to find out what is A2 cross A3. Since there are two variables for all of them, let's find out by the determinants. So A1 was, sorry, A1 cross A2, I have written it A1 cross A2, V3 is A1 cross A2. So this is A1 cross A2, and A1 is root 3a by 2 x cap, a by 2 y cap 0. This is minus root 3a by 2 x cap, a by 2 y cap 0. So x cap is 0, y cap is also 0, there will be only z cap, and that will be root 3a square by 4 plus root 3a square by 4 z cap. So it is root 3a square by 2 z cap. If we put down, that will be root 3a square by 2 z cap divided by root 3a square c by 2. So root 3 by 2 cancels out, a square cancels out, only c, 2 pi by c z cap. Yes, so this is the reciprocal lattice vectors of. So if you see the reciprocal lattice vectors b1, b2 and b3, then you can see that this is also similar to what was a1, a2 and a3. So the hexagonal lattice is the reciprocal of hexagonal lattice is also a hexagonal lattice with different lattice constant. So is this clear, the how I calculate the reciprocal lattice vectors of hexagonal lattice? So this is this was a straightforward question.
I have one doubt. HCP is reciprocal of HCP, sir. That means that value is coming for same is not valuable.
No, like ACP's ACP's reciprocal lattice is also an HCP lattice, but the lattice constants are not same. It will be opposite to that. Like it was C for the direct lattice, the A3 vector was CZ, but for the reciprocal lattice it is 2 pi by CZ. So this reciprocal lattice vectors will not be same. You can calculate the volume also. Yeah, so also calculate the volume of this reciprocal lattice vectors, then you will see that it will be b1 dot b2 cross b3. So b2 cross b3 is, what is b2? b2 we have calculated as 2 pi by root 3a into minus x cap plus root 3 y cap cross 2 pi by c z cap. So 4 pi square divided by root 3 ac. Now x cap into z cap is minus y cap, and also there is one minus sign, so it will be y cap, and y cap in z cap is x cap. So you will get this as b2 cross b3, and if you do the dot product with b1, then you will get, so what is b1? b1 is 2 pi by root 3a x cap plus root 3 y cap. Is it so? Yeah. So into dot product with 4 pi square by root 3 ac into y cap plus root 3 x cap. That will be 8 pi cube divided by 3 a square c into root 3 plus root 3, that is 2 root 3. So 16 pi cube by root 3 a square c. So this is the volume of the reciprocal lattice, and the volume of the direct lattice we have already calculated as root 3 by 2 a square c. So you can see that it is just 2 pi cube divided by volume of the real space lattice, as it should be. So
Okay,
this,
sir. Thank you. Thank you.
yeah. Is there any more question? So since I was doing that structure factor and all, so you can solve problems from there. So yeah, I think structure factors problem was also solved in the previous. Okay, let me just find out one problem. Give me just 1 minute. I'll write down a problem from the structure factor. And please solve the question for diamond lattice. That is show what values of for what values of HKL the structure S value is non-zero.
Okay, sir.
So I have written down the problem there. So this question was a previous question from net. I think I have already discussed it in the class. I'm still gonna write the question here. A beam of X-ray is incident on a BCC crystal if the difference between the incident and scattered wave vectors is k, which is equal to n x cap plus k y cap plus l z cap, where the unit vectors of the associated cubic lattice, where x cap y cap, where x cap y cap and z cap are the unit vectors of the associated cubic lattice, then the necessary condition for the scattered beam to give a law maximum is option A is h plus k plus l equal to even, option B is h equal to k equal to l, option C is h k l are all distinct, and option D is h plus k plus l equal to odd. So I think I have already discussed this, but still, can you say what option will
Sir,
be correct?
option A.
Yeah, so in the this is a VCC structure and the reciprocal lattice vector, so you see that the difference between the scattered vectors is what is the reciprocal lattice vectors, because k prime minus k would be g, so this is the reciprocal lattice vector. So in terms of, I think it is h, sorry, it is not n, h k and l. So as I have did already in the first part of the class, that for a VCC structure, where is the VCC structure? So for the VCC structure, if v1 plus v2 plus v3 all are even, if all are even, then s equal to 2f, but if not all are even, sorry, if the addition of these three numbers is even, then s equal to 2f, and if the addition is odd, then s equal to 0, and for other s equal to 0. So the condition for this question satisfy for option A, that h plus k plus l has to be equal to 0.
Sir, even.
So option A is correct, yes. Then because for option A the maximum maxima will be present, then the plane will, this plane will be present, so that was done from this formula, that A is equal to F into sum over of n equal to 1 to n effective. So there is 2n e to the power 2 pi I h u n plus k v n plus l w n. And for BCC there are 2 points at 0 0 0 and half half half. So it will be f into e to the power 2 pi I into 0 plus e to the power 2 pi I into half into h plus k plus l, and that will give us f into 1 plus e to the power I pi or minus I pi, it doesn't matter, plus h k plus l. And so if all of them are even, if h plus k plus l are even, then this is value will be 1 plus 1, that is 2f, and if h plus k plus l is odd, then s is equal to f into 1 minus 1, that is 0. And the intensity will be I equal to s square, which is 4f square. And if all of them are if the addition is even, and if not, then it is 0. This is for h plus k plus l equal to even, and this is for h plus k plus l equal to odd. So remember where the atoms are. So for BCC these are 0 0 0 and half half half. So that's how the basis is formed for BCC. So option A is correct. Yes. So if you can calculate for diamond, this picture will be very much clear for you, how to calculate the structure factor and all. Do you have any question here? So from today's classes, do you have any question about anything? So yeah, definitely I'll solve that question from assignment 4. Question number 6, I think, right? So assignment 4 of this is assignment 5, which I should not be discussed now. So assignment 4. So someone was pointed out to solve assignment 4, question number 6 of assignment 4. So I'll solve this question and add to this note, and we can discuss this in the next class also. Rest of the questions everyone solved. So I think assignment 8 question number 8 is also regarding this S value. So if you can solve question number 6, then assignment question number 8 will also be solved easily. And other questions are okay, question 9 is also about this S value, and the rest of the question is easily solved by using the 2D sin theta equal to n lambda formula. So apart from this, any other question or doubt?
No, sir.
Hello, sir.
Yes, hello.
Sir, I am facing problems to solving the questions based on the powder diffraction, camera radius, and
Yeah, that is
yes.
so that was we were discussing in the start of the class, that we'll solve question number 6 and we'll add to this today's note. So if we solve question number 6, then question number 8 9 will also be solved in the similar way. So it is again same question regarding this power S values, powder diffraction. So I'll solve one question from this type of question, and then I will add to this today's class note, and I'll update this in the link. So I have already shared the weekly log sheets link to the chat box. You can access there, or maybe I can copy and okay. I'll share this again to this chat box. How to so we'll get the link. So using this link you can get all the YouTube videos and also all the lecture notes there. Everyone got the link, right? So you can find it in the chat box. So I'll stop sharing then. I'll upload this class note. You can find it in the Google Drive link. So if
Okay, sir. Thank you.
yeah, so if there is no question, then we'll end the session today. Is there any question? Else, let's meet in the next class. Sure. Okay. So see you in the next class. Bye.
Thank you, sir.
Thank you.